As part of our 2015 release, a new perfectly matched layer absorbing boundary condition will be available in FTTD and mode solutions. The new PML can be found under the Boundary Conditions tab associated with the FTTD and bar FTTD solvers. The new PML, which is based on a stretch coordinate formulation, offers better absorption and better numerical stability than the previously offered PML, which was based on a uniaxial anisotropic material formulation. Now, just as a brief reminder, a PML is a type of boundary condition that allows you to simulate an infinite space with a finite computational grid. And a very simple example that illustrates this point is shown on the screen. What we have is a magnetic dipole in free space surrounded by PML boundaries on all sides. As you can see, as the dipole fields are generated, the PML boundaries absorb all of the incoming light. This absorption process is what allows you to model an open space or an infinite space using PML boundaries. As I was mentioning before, the new PML offers better numerical stability and better wave absorption than the previously offered PML, and this ultimately translates into faster and more accurate simulations. As part of the development of the new PML, a new user interface has been introduced that allows you to choose the proper PML parameters easily based on the intended application. To emphasize these points, I will show you a brief example. So here you can see a three-dimensional waveguide excited by a surface plasmon. This type of simulation is difficult to do because it can cause numerical instabilities in the PML region. I will briefly show you that when the old PML is used, a numerical instability will appear. And I will also show you that with comparable parameters, the new PML does not have such numerical instability. So on the screen, you can see two videos that show you how the simulation progresses as a function of time. As you can see in the first video, with the old PML, a numerical instability appears in the PML region after a relatively short period of time. However, as you can see in the second video, with comparable parameters, the new PML does not develop such numerical instability. With the new PML, you can let the simulation run for a very long period of time and you will not see any numerical instabilities. In addition, in this example, using the same settings on all boundaries can be inefficient because a large number of layers is only needed along the horizontal or x-axis. The new PML user interface allows you to set the PML parameters individually for each boundary. And as you can see on the screen, by using custom settings for each PML boundary, we were able to bring down the simulation time from 76 to 12 minutes for this particular example. So, this was just a brief example of how the superior numerical properties of the new PML will allow you to obtain more accurate simulations, and of how the new user interface can be exploited to make your simulations faster. If you have any questions about the new PML, please do not hesitate to contact us or to send us an email to support@lumerical.com. Thank you.